going to use an example of a type of area we already know to talk about how to find the area of a new shape that we might not know. So first of all, I want to turn your attention to the square right here. And we all know how to find the area of a square, that you multiply how wide the square is, so the base times the height. Now, here's a shape that we don't necessarily aren't as familiar with. This guy right here, he's a parallelogram. Now, the reason he's a type of parallelogram that's not a square is, of course, he doesn't have right angles. So he's just got, kind of looks like a square or a rectangle that's been smushed. And sometimes it's hard for people to find the area of a parallelogram. Well, notice right here, over here to the side, I've taken the parallelogram and I've chopped it into two pieces. Okay, so it's still the same parallelogram that I have right here. Notice when I put it on top of it, it's the same, but I've chopped it in half. So then, if I just go, voila, go swoop, and scoot that around, look, all of a sudden it's become a square. So it's really the same thing as a square. It's just that the space it takes up has kind of moved around a little bit. So it's really kind of the same thing. Again, see how a square and a parallelogram are really similar, because if I take this parallelogram and I chop it in half and I go, ooh, I can actually turn it into a square. Well, what does that have to do with finding the area? Well, let me show you what that has to do with it. Because a parallelogram really is the same thing as a square as far as the amount of area it takes up. See right here in the example I have, if I just kind of chop this right here at the dotted line, and if I move this part over, it would actually turn into a rectangle. So the reason that's important is because the formula for the area of a rectangle is the same, the formula for the area of a parallelogram is the same as it is for a rectangle, even though they don't necessarily look alike. You're still going to find the area, you're going to do the base times the height, just like you would if it were a rectangle. So that means I'm going to multiply this 15, because that's the base. Now, which one is the height though? I've got two numbers here. I have a 7 and I've got a 5. Okay, they put that 7 there to kind of mess with you a little bit. That's not the height. When you're finding your own height, you'd measure yourself the way that you're standing up straight, right? Not the way that you're leaned over, like this side is right there. That's called the slant height. That is not the height that we need. You're always going to need the height that is straight up and down, just like this one right here. Okay, so we're going to take 15 and multiply that by 5, which means our area will be 75, and then notice that this is out of centimeters. So it'll be 75 centimeters squared. So now you try this one really quickly. Pause the video, try it out, see whether or not you get it. I'm going to assume that you've gone ahead and worked it. And the first thing I noticed on this one, well, a couple things. So they gave me this slant height again, which I do not want. Okay, I just want my plain old straight up and down height. But then they also went and changed these units on me. Hopefully we know that a foot is 12 inches. So I'm going to change it to 12 inches, that I have inches just like I do here. Okay, and I'm going to do, again, my base times my height, which means my base is this 12 inches, and then my height is 8. So I'm going to do 12 times 8, which is 96. I need to put the units in there. So it's 96 inches squared. So again, the formula for the area of a parallelogram is exactly the same as it is for a rectangle. You just have to be careful not to, when they give you that slant height right there, don't use that one. You're always going to want to use your regular vertical up and down height.